Welcome back, my dear students. So today also we continue our topic, that is problem solving using the principle of mathematical induction. Okay, so today's problem is prove by mathematical induction that a plus a into r plus a r square plus etc. plus a into r power n minus 1, that is equal to a into 1 minus r power n whole divided by 1 minus r for all n belongs to n. We have to prove this by using the principle of mathematical induction. So observe this. This is a formula to find the nth term, sum of nth term for the geometric series, right? So we prove this formula by mathematical induction. So first of all, take this statement as p of n. So p of n, let p of n is equal to what? A plus ar plus ar square plus etc. plus a into r power n minus 1 is equal to a into 1 minus r power n whole divided by 1 minus r. So next, step 1. So what is our step 1? Step 1 is prove that p of 1 is true, right? So prove that p of 1 is true. So we have to prove that p of 1, when n is equal to 1, the given statement is true. We have to prove this one, right? So when n is equal to 1, so LHS becomes what? When n is equal to 1, it becomes only one term. So the first term is a, right? So what is RHS become when n is equal to 1? Put n is equal to 1. So this becomes a into 1 minus r power n. N means here what now? 1 divided by 1 minus r. So a into 1 minus r power 1 is nothing but r divided by 1 minus r. So 1 minus r and 1 minus r gets cancelled. So the remaining is a. So both LHS and RHS are equal to what? A. So therefore LHS is equal to RHS. Hence P of 1 is true. So now we prove that P of 1 is true. Next we move on to the step 2. So what is our step 2? Step 2 is assume that P of k is true. So we have to assume that the given statement is true for some k, right? So that is, then the statement becomes what? A plus ar plus ar square plus etc. plus a into r power k minus 1. In the place of n we have to put k, right? That is equal to, so the RHS becomes a a into 1 is a minus a into r power k plus a into r power k into 1 is what? A into r power k. So plus into minus becomes minus. Then we have r into a into r power k. So it becomes a r power. Here we have power k. Here we have 1. So it becomes k plus 1. So a into r power k plus 1. So now whole divided by what? 1 minus r. So minus a into r power k plus a into r power k gets cancelled. So the remaining terms are a and the last term, that is minus a into r to the power of k plus 1 whole divided by what? 1 minus r. Now take the common factor. What is the common factor in numerator? A, right? So that is equal to, take a as the common factor. The remaining is, if you take a outside, the remaining term is 1 minus, here we take a as the common factor. The remaining term is r to the power of k plus 1 whole divided by what? 1 minus r. Observe that this is our RHS, a into 1 minus r power k plus 1 divided by 1 minus r. This is what our RHS. Therefore, P of k plus 1 is also true. So all the three conditions are satisfied. Hence, by the principle of mathematical induction, the given result is true for all natural numbers. The given result is true for all natural numbers. Understand? So we move on to the next one. Problem is, prove by mathematical induction that 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 etc. into 1 plus 2n plus 1 divided by n square. This is the nth term, that is equal to what? That is equal to n plus 1 the whole square for all n belongs to n. So we have to prove this by mathematical induction. So this is the problem. 1 into 3 plus 1 into 1 plus 5 by 4 into 1 plus 7 by 9 etc. into 1 plus 2n plus 1 divided by n square is equal to what? N plus 1 the whole square. We have to prove this by mathematical induction. Okay. So the first, let the given statement as P of n. So P of n becomes 1 plus 3 by 1. So here we have into 1 plus 5 by 4 into 1 plus 7 by 9 etc. into 1 plus 2n plus 1 divided by n square is equal to what? N plus 1 the whole square. So we move on to step 1. That is, step 1 is prove that P of 1 is true. Right? So what happens when n is equal to 1? When n is equal to 1, the LHS becomes consider only the one term. When n is equal to 1, so this is nth term. It has n number of terms. So when n is equal to 1, we have to consider the first term only. So that is 1 plus 3 by 1. Right? So this is nothing but 1 plus 3 by 1 means 3. So 3 plus 1 is equal to what? 4. So LHS becomes 4. When come to RHS, so this is our RHS. Put n is equal to 1. So RHS. So when n is equal plus 1 the whole square, right? 1 plus 1 is 2 whole square. 2 square is nothing but 4. So both LHS and RHS are equal to 4. So therefore LHS is equal to RHS. Hence P of 1 is true. So the first step is completed. So next step 2, that is assume that P of K is true. Okay, then the statement becomes what? That is, the statement becomes 1 plus 3 divided by 1 into 1 plus 5 divided by 4 into 1 plus 7 divided by 9 into etc. into 1 plus 2n plus 1 divided by n square is equal to, here this is P of K. So we have to replace n by K. So 2K plus 1 divided by what? K square is equal to K plus 1 the whole square. This is what our P of K. Replace n by K. We have to assume that this statement is true. So next step 3. Step 3 is what? Prove that P of K plus 1 is true. So we have to prove that P of K plus 1 is true. Then the statement becomes, write on the statement, 1 plus 3 divided by 1 into 1 plus 5 divided by 4 into 1 plus 7 divided by 9 into etc. into 1 plus 2K plus 1 divided by K square into. So here we don't have addition, here we have multiplication. So into, write on the next term, that is K plus 1, the term is 1 plus. So here we have 2K plus 1. So 2 in the place of K, put K plus 1 plus 1. So it becomes 2K plus 2 ones are 2 plus 1. It is nothing but 2K, 2 plus 1 is 3. So 1 plus 2K plus 3 divide by what? K square. So the K plus 1 the term is K plus 1 the whole square. This is our LHS. That is equal to what? So here we have K plus 1. Put K is equal to K plus 1. So K plus 1 put it becomes K plus 2, right? So that is equal to K plus 2 the whole square. We have to prove that this is equal to K plus 2 the whole square. Okay. So for that, consider the LHS again. So consider into 1 plus 5 divided by 4 into 1 plus 7 divided by 9 into etc. into 1 plus 2k plus 1 divided by k square into the last term is what? 1 plus 2k plus 3 divided by k plus 1 the whole square. I consider this LHS. I have to prove this is equal to k plus 2 the whole square. So from step 2, so from here up to k term is equal to what? K plus 1 the whole square into what? The last term 1 plus 2k plus 3 divided by k plus 1 the whole square. Okay. So now what is the LCM? Sorry, first also